Welcome to the Probability Class 10 NCERT textbook examples video. In this video, we will see probability examples questions, and in the coming videos, we will see the textbook questions as well. Now we will see some basics of probability. Okay, so first of all, probability is equal to favorable cases by total number of cases, total number of outcomes. So this is the standard definition of probability. What actually this means is, suppose if we flip a coin, if we flip a coin, then we will either get heads or tails. So if somebody asks what is the probability of heads, then I can write it as 1 by 2. And what is the probability of tails? That is also equal to 1 by 2. So here 1 is our favorable case. So here 1 is our favorable case and 2 is the total number of cases. Now probability of any event always lies in between 0 and 1. So in this case you can see that probability of heads is equal to 1 by 2 and probability of tails is also 1 by 2. Probability of all the events, so probability of heads plus probability of tails is equal to 1. So here in this slide, basically I wanted to say two things. The definition of probability is ratio of favorable cases by total number of outcomes. Suppose if we flip a coin, then the probability of heads is 1 by 2 and the probability of tails is also 1 by 2. Here 1 is the favorable case and 2 is the total number of case. Second thing which I wanted to say is this, that probability always lies in between 0 and 1. And sum of all, if suppose probability of getting a head is an event, probability of getting a tail is an event. So suppose probability of an event E plus probability of an event which is not E, so it is generally denoted by P of E bar, is equal to 1. So here probability of head plus probability of tail I can also write as probability of head plus probability of head bar, that is probability of not head, is equal to 1. This is the first example question. So when we toss a coin, right? When we do that, there are two outcomes, either heads or tails, correct, right? So probability of getting a head is equal to 1 by 2. Probability of getting a tail is equal to 1 by 2, right? So here what he has asked is that a coin has been tossed once. So when a coin is tossed once, we can either get a tail or we can get a head. That's what I have written, and the probability of each being 1 by 2. So as I was explaining in the earlier slide as well, that a probability of head plus probability of tail is equal to what? 1 by 2 plus 1 by 2 is equal to 1. Also find the probability of getting a tail. So as we discussed earlier as well, that if a coin is tossed, then there are this coin, then when you toss it, you can either get a head or you can get a tail. So so if this is E1, so this is E2, event 1 and event 2. So probability of all the events, pure E1 plus probability of E2, like that, probability of En is always equal to 1. So here we only have two events, that head and tail. So similarly I have written that probability of head plus probability of tail is equal to 1. So answer to this question is this, that find the probability of getting a head when a coin is tossed. Probability of head is what? 1 by 2, and probability of tail is also 1 by 2. We'll see the next question. This question is, there is a bag, okay? This bag contains a red ball and it contains a blue ball and it contains a yellow ball, all the balls being of same size. When they say that all the balls are or of the same size, what actually they means is the probability of bringing them out from the bag is the same. Okay, Kritika takes out a ball from the bag without looking into it. What is the probability of a yellow ball? See, bag contains, the bag which we are talking about, it contains 3 balls, right? One is red, another one is blue, and another is yellow. So probability of red is what? 1 by 3. Probability of blue is 1 by 3, and similarly probability of yellow is 1 by 3. Why I am writing 1 by 3? 1 by 3 means there are total 3 number of balls, and this 1 actually represents that blue is one among them. Here also the same, that total probability means total number of favorable cases, as we discussed at the very first slide, that probability basic means favorable cases by total cases. So here probability of a, if I say probability of red, means what is the probability, what are the cases favorable to red, that is 1, and what are the total number of cases? 3. So probability of yellow, red and blue all are 1 by 3, 1 by 3, 1 by 3. So here we can say that they all are equally likely. If you read the textbook, you will get to see this term. What equally likely means, suppose if I toss a coin. So as I said, if I toss a coin, the probability is that I will get either head or a tail. So probability of head is what? Is 1 by 2. Probability of tail is what? 1 by 2. So the probability of getting a head and the probability of getting the tail is same. So I say that both of them are equally likely. Similarly, if I see this example, I have a bag in which I have a red and I have a blue ball and I have a yellow ball. So, and the probability of each one of them, probability of getting a red is 1 by 3, blue is 1 by 3, and yellow is the answer. I will write it down here. So probability of yellow is 1 by 3, probability of red is 1 by 3. This is the answer to the question actually. Probability of blue is also 1 by 3. So we see that the probability is for all of them is 1 by 3, 1 by 3, 1 by 3. Therefore they are also said to be equally likely. This is the third example from the textbook. Now the question is, suppose we throw a dice. Suppose we throw a dice. Suppose, okay, a dice. A dice has generally 1, 2, 3, 4, 5, 6 faces, right? So what are the probability of getting 1 is what? 1 by 6. Probability of getting 2 is what? 1 by 6, right? Similarly, probability of getting 6 is what? 1 by 6. So all of them are equally likely, as we were discussing in the earlier example. Equally likely means the probability of getting 1 is equal to probability of getting 2. So if I write like this, probability of getting 1 plus probability of getting 2 plus probability of getting 3 plus probability of getting 4 plus probability of getting 5 plus probability of getting 6, right? So what is it? So it will be like 1 by 6 plus 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 1 by 6, right? So is equal to what? 1. So as I was telling you that probability of any event always lies in between 0 and 1, and sum of all, P of E1 plus P of E2 plus P of En is equal to 1. That's what I was showing you. Now coming back to the question. Now the question is, suppose we throw dice once. So if we throw a dice, then these are the possible outcomes, right? 1, 2, 3, 4, 5, 6. What is the probability of getting a number greater than 4? Greater than 4, meaning 1, 2, 3, 4, 5, 6. Greater than 4, meaning 5 or 6, right? Not equal to 4. It is only greater than 4. Then we can get 5, 6 by like 1, 2, 3, 4, 5, 6. We can write. So what is it? 2 by 6. This is 2. 2 by 6 is what? 1 by 3. Right? 5 and 6. So the probability of getting a number greater than 4 is 1 by 3. Okay. Now question number 2. Okay. Question number 2. What is the probability of getting a number less than or equal to 4? Now probability of getting a number greater than 4 is 1 by 3. Probability of getting a number less than or equal to 4 meaning 1, 2, 3, 4, right? So the probability of getting a number less than or equal to 4 is 1 by 3. Probability of getting a number greater than 4 is 2 1 by 3. Probability of getting a number less than or equal to 4 meaning 1, 2, 3, 4, right? So the probability for this of getting a number what is it less than 4 is what? 4 by 6 is what? 2 by 3. So this is the answer. So the answer for the first one, what is the probability of getting a number greater than or equal to 4 is what? Is 1 by 3. And for the second question, what is the probability of getting a number less than or equal to 4 is 2 by 3. So this is example 4 of the textbook. So the question is, one card is drawn from a well shuffled deck of 52 cards. Calculate the probability that the card will be, question number 1, ace and not an ace, right? So first of all, cards generally has 4: spades, hearts, diamonds, and the fourth one is clubs. So it is like spades, diamonds, hearts, and clubs. So it is like king, queen, jack, 2, 3 up to 10. King, queen, jack, 2, 3 up to 10. King, queen, jack, 2, 3 up to 10. And similarly for clubs, king, queen, jack, 2, 3 up to 10. So what actually I want to say is, in each of these, so it is like 13 plus 13 plus 13 plus 13 is equal to 52. 13 fours are 52. And here diamonds and hearts, they are red in color basically, and the other ones, heart, spades and clubs are black in color. So coming to the question, probability of B and ace. The thing is, like in each one of them, king, queen, jack, sorry, I have missed ace. Here there will be an ace as well. Ace is basically 1. Okay, so in each one of these there will be an ace. So one ace here, 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 and here. So the answer is for this like 4 by 52. This is like 1 by 26. 2 by 26 is equal to 1 by 13. So probability of an ace is 1 by 13. Now the next question is probability of not an ace. So I discussed this even earlier. So probability of an event plus probability of not an event, EVENT, is equal to 1. So probability of ace plus probability of not ace, A bar is not ace, is equal to 1. So we want now for the second question probability not be an ace. So P of A bar is equal to 1 minus P of A is equal to 1 minus 1 by 13 is equal to what? 12 by 13. So this is the answer. Thank you. This is example 5. There are two players, Sangeeta and Reshma. They play a tennis match. It is known that the probability of Sangeeta winning the match is 0.62. What is the probability of Reshma winning the match? This is the same as I said, probability of an event plus probability of not an event is equal to 1. Or I can also put it as, if there are suppose n events, probability of E1 plus probability of E2 plus probability of E3 plus like that probability of En is always equal to 1. The sum of all the probabilities is always equal to 1. So in this question there are two, probability of Sangeeta plus probability of Reshma winning a match. Okay, winning a match. Similarly here also Reshma winning a match. The probability of both of them is always equal to 1. As per the question it is 0.62, right, for Sangeeta. So 0.62 plus probability of Reshma winning a match is equal to 1. So from this, sorry for the bad handwriting, so probability of Reshma is what? 1 minus 0.62 is what? 0.38. So this is the answer. Thank you. Now coming to example number 6. There are two friends, Savita and another is Hamida. So Savita and Hamida are friends. What is the probability that both will have different birthdays? Okay, so first question is probability of both have different birthdays, and second question is probability have same birthday. Now there is one thing in the bracket, that ignoring a leap year. First of all, what is a leap year? Leap year has 366 days. Non-leap year, it has what? 365 days. So we are talking about a non-leap year, right? Now see, now answer to this question. So this first one, both have different birthdays. Suppose Savita has a birthday on one of the day, okay, any one of the 365 days. Okay, suppose any one of the 365 days. Savita has birthday on one of the 365 days. Now, if both of them are different, Hamida, so out of 365, one is gone, right? So 364. So Hamida can have birthdays on any of the remaining 364 days, correct, right? Therefore, probability of both having different birthdays is 364 by 365. I hope this is very clear. The thing is, this is a non-leap year, so there are 365 days. That's why the denominator is 365. Okay. Now, suppose Savita has birthday on one of the days. Suppose any one of the day. Hamida is not supposed to have birthday on that day, right? Because both of them has different birthdays. So then Hamida can have birthday on remaining days, that is 364 of the 365 days. Therefore, the probability is 364 by 365. Now, probability of question number 2. Okay, same birthday. Now there are total 365 days in a non-leap year, and we want to have birthdays on the same day. Then it is 1 by 365, right? Also, we can also solve this question like this. As I said, that probability of an event plus probability of not event is equal to 1, right? So from the first question, they have different birthdays. Different birthday is this, suppose. Then what is our 364 by 365. So probability of an event plus 3 is equal to 1. So probability of an event is 1 minus 364 by 365 is what? It's 1 by 365. This is the answer to the second question, right? Different, same birthdays. I hope this is clear. It is very simple. See, we read the question once again. Savita and Hamida are friends. What is the probability that both will have different birthdays? So here I have explained this, is that in a non-leap year there are 365 days. If suppose Savita has birthday, there are suppose 1, 2, 3, and there are total 365 days. Suppose Savita has birthday on this day, then in order to have different birthdays, Hamida can have birthdays on all these remaining days. So these are our favorable cases. So what are they? 364 in number, right? Because total is 365. So probability of both having different birthdays is 364 by 365. Now to the second question, they have the same birthday. Same birthday means out of the 365 days, both should have it on the same birthday, same day. That is 1 by 365. This is one way of solving it. Another way is, as we have been seeing it all around, that probability of an event plus probability of not an event is equal to 1. Suppose if we say that probability, this is for same birthday, event is nothing but same birthday. So probability of event plus not event is 360 is equal to 1. Then probability of event is equal to 1 by 365. This is what is the answer for the second question. This is example 7. There are 40 students total in a class of class 10th of a school, whom are 25 are girls and 15 are boys, right? So 25, 35, 40. So 25, plus 15 is equal to 40. Correct, right? So these are the total. Class teacher has to select one student as class representatives. She writes the name of each student on a separate card, the card being identical, meaning all of them, the probability that any one of them can become a class representative. So all they are equally likely, equally likely events. Okay, so can so anybody can become a class representative. So anybody can become a class representative. She puts the card in a bag and stirs them thoroughly. Then she draws one card from the bag. What is the probability that the name written on the card is name of a girl? So the answer 1 is like probability of a girl is what? 25 by 40. Correct, right? Because there are 25 girls. And second one, probability of a boy is what? 15 by 40. Understood, right? This is very simple question. There were total 40. There are 25 girls and there are 15 boys. Now this is the total number of cases. This is cases favorable to girls. Cases favorable to, these are cases favorable to boys. Favorable to boys. Now the first question is, what is the probability that it is a girl, right? So how many girls? 25 girls, correct, right? So 25 by 40. How many boys? There are 15 boys, 15 by 40. Now coming to example 8. A box contains 3 blue, 2 white and 4 red marbles. Okay, so for sake of simplicity I will write 3 blue, 2 white and 4 red marbles. If a marble is drawn randomly, what is the probability that what are the total? Total is what? 3 plus 2 plus 4 is what? 4, 5, 6, 7, 8, 9. Correct, right? 4, 5, 6, 7, 8, 9. Yes. So answer to the first one, probability of white. White, how many are white? 2. So 2 by 9. Second question, probability of blue. How many blue? 3. 3 by 9. And third one, probability of red. How many red? 4. 4 by 9. 4, 5, 6. So if you see, if we add all of them, as I was saying, the probability of any event, this is the most important thing in probability, is always in between 0 and 1. If a probability of any event is 1, then it is also called as sure event. And if the probability is 0, it is also called as impossible event. Okay. So, and as I was also saying that P of, suppose there are n events, similar, if you can see here that probability of getting a blue, white and red, these are 3 different events, right? So if I can write probability of E1 plus probability of E2 plus probability of E3 is always equal to 1. That you can see from here also, right? 2 by 9 plus 3 by 9 plus 4 by 9 is always equal 4 plus 3, 5, 6, 7, 8, 9 by 9. So these are all some small things which I think by now you would have understood, right? So the answer to the question, white is 2 by 9 as there are 2 white balls. Blue is 3 by 9 as there are 3 balls. And red is 4 by 9 as there are 4 red balls. And if we add all of them, 4, 5, 6, 7, 8, 9, that's why the denominator is 9. Now coming to example number 9. Harpreet tosses 2 different coins simultaneously. Say one is of 1 rupee and another is of 2 rupee. What is the probability that she gets at least one head? Okay. Now see, if suppose we toss 2 coins. Okay, so 1 rupee coin and another is 2 rupee coin. What can we get? We can get head head, head tail, tail head and tail tail. These are the all possible outcomes. All possible. So here instead of it can be 2 1 rupee coins as well. So if we suppose to toss 2 coins, it can be like head head, head tail head and tail tail. Correct. Now it gets, now the question is probability of at least one head. At least one head. What actually it means is probability of one head or probability of two heads. This is what it means. Out of these, see, this is one, this is one outcome, this is one outcome, one, at least one. At least one means one or more than one. At least one. At least one actually means one or more than one. In this case, more than one means it can be two, right? At least one head. See, here it can be at least one head. Here also at least one head. It can be more than one head, right? Two heads. So what is the probability? 3 by 4. Why 3? 3 is because you can see that these two and this one. So they are 3. And what are the total number of outcomes? 4. So 3 by 4. This question can also be solved in another method that I am writing it as second method. And what is it? Let us see. At least one also means total minus none. You will understand this as we go along. So what is total probability is always 1 minus none. What is the probability of getting no heads? See, if you toss two coins, head head, as I told you, head tail, tail head, and tail tail. This is one event, this is second one, this is third one, and this is fourth one, right? None. Here you don't have any heads. So what is this probability? 1 by 4. So 1 minus 1 by 4 is 3 by 4. So this is the answer which we got even earlier, that the probability of getting at least one head is 3 by 4. In a musical, this is example 10. In a musical chair game, the person playing the music has been advised to stop the music at any time within 2 minutes. After she starts playing, what is the probability that the music will stop within the first half minute? Suppose if I start from here, okay, I will divide it. This is 0th minute, 0 minute, and this is 2 minutes. I will now this is what? This is 1 minute, half 1 minute, and this is 30 seconds, 31, and this is what? 90. So these are 4. This is 1, this is 1, this is 1, this is 1. So I want now probability of music within the first half minute. Within the first half, this is the probability. So my thing is, I need to get this. What is the probability? This is what? 1 out of 4. Correct, right? 1, 2. There are 4 such things is equal to 1 by 4. So the total is, suppose the total 2 minutes I have divided into 4 parts, and I want my outcome to be in the first part. So the probability of this event within first half minute, is 1 by 4. Example 11. This question is very simple. A missing helicopter is reported to have crashed somewhere in the rectangular region as shown in figure 15.2. This figure is 15.2. What is the probability that it crashed inside the lake shown in the figure? So as I told always at the very beginning, that probability can be defined as favorable outcomes by total outcomes. So here it could have fallen anywhere in this lake is what they are saying. We need to find what is the, so I have to write that area of the lake by total area. Generally people see figures and they think that the question is very hard and they leave it, but most of the times when you have figures it is very simple. What is the total area? Total area is what? Area of a rectangle. Total area is what? Area of the rectangle. And what is that? It is nothing but 4.5 into 9 kilometer. Correct, right? So this 4.5 into 9, whatever the number is. So the denominator is 4.5 into 9. Now what about the numerator? I need to know what the numerator is. So this part, this area, this area, as you can see, is what, 4.5 minus 2, right? So 4.5 minus 2 into here, this is this area. Now this area is what, 9 minus 6 is what, 3. I will write it like this, 9 minus 6. So if you see this, 4.5 minus 2, 3.5, 2.5, 2.5 into 3 by 4.5 into 9. You can do the calculation, then you will get the answer. Now we'll just see 2.5 into 3 is how much. Into 3 is 7.5. So this probability is what? So probability is equal to 7.5 by, so I'm just writing the same thing, 7.5 by and 4.5 into 9 is what, 40.5. So this is the answer. This is 40.5. So this is the answer. Always you have to see that these number, this is only for your intuition, this number should be always in the smallest fraction possible. Suppose if I write 20 by 40, you should not leave it like this. It should be like, 10 by 20, then this should be 5 by, this is 10 by 20, this is 5 by 10, you can do 1 by 2. So 1 by 2 is the probability, like that. So the answer to this question is 7.5 by 40.5, and the answer is like area of the lake. Whatever is the area of the lake, as you can see, this into this, like length into breadth, right? So area of a rectangle is length into breadth. So this is important. This is what I used here. This is example 12. A carton has 100 shirts. Okay, 100 shirts. 88 of them are good. 88 good. 8 have minor defects, and 4 has major defects. So a carton has 100 shirts, of which 88 are good, 8 have minor defects, and 4 have major defects. Jimmy, there are 3. Jimmy, a trader. He's a Jimmy. Jimmy, I think I should. So Jimmy, sorry, yeah. Jimmy, a trader, will only accept that are good. Okay. Sujata will reject the shirts which have major effect. Rejects shirts with major defect. Now, out of these 100 shirts, right, total probability which is favorable to Jimmy, there are total 100 shirts, right? Out of this, Jimmy only takes the ones which are good. Out of 100, only 88 are good, right? So 88 by 100 is answer for Jimmy. And we have to simplify it further. This is about 44 by 50. This is about 22 by 25. This is the answer. Now, probability of Sujata. Sujata rejects shirts which have major defects. So, but she will accept. So probability of minor defects plus good by total. So Sujata basically will take shirts with minor defects, and she will also take shirts which are good, but she will reject the ones with major defects. So what is it? Total 88 plus 8 by 100. What is that? This is what, 96 by 100. You can simplify it. 96 by 100 is what, this is by 50, and this is 4s are 8, 2 8s are 16, right? 48, and this is what, 24 by 25. This is the answer, 24 by 25. This is example 13. Two dice, one blue and one grey, are thrown at the same time. Write down all the possible outcomes. See, suppose if two dice are thrown, okay, suppose I have dice 1. What are the 1, 2, 3, 4, 5, 6. Similarly for dice 2, what are 1, 2, 3, 4, 5, 6, right? So what are the all possible outcomes for 1? Suppose on the first dice I have 1. So here it will be like first dice, comma, second dice. This is how I will be writing. So suppose if I get 1, 1 comma 1, 1 comma 2, 1 comma 3, 1 comma 4, 1 comma 5, 1 comma 6. Similarly 2 comma 1, 2 comma 2, 2 comma 3, 2 comma 4, 5, 2 comma 6, 3 comma 1, 3 comma 4, 3 comma 5. Similarly this one 4 comma 1, 4 comma 2, 4 comma 6. Similarly I can write 5 comma 1, 5 comma 2, 5 comma 6, and the last one is like 6 comma 1, 6 comma 2, 6 comma 6. Now the total possibilities is what? So probability is what? Favorable cases by total cases. Total cases. So now total cases is what? 36 actually. If you count all of them, 6, 1, 2, 3, 4, 5, 6, 6 into 6 is 36. Okay, now we'll come to the question favorable cases. Now let us solve this thing. Probability of getting an 8. When can we get an 8? 2 comma 6 will give an 8, 3 comma 5 will give an 8, 4 comma 4 will give an 8, 5 comma 3 will give an 8, and 6 comma 2. We have to understand that 2 comma 6 and 6 comma 2 are not the same. So 1, 2, 3, 4, 5. So probability of getting an 8 is what? 5 by 36. This is the answer to the first question. Second question is very important. 13. What is the probability of getting a 13? Suppose we have two dice, 1, 2, 3, 4, 5, 6. Dice 2, 1, 2, 3, 4, 5, 6. The maximum number of first dice is 6 and the maximum number of second dice is 6. If we add both of them, we get 12. So there is no chance of getting 13. So actually probability of getting is an impossible event. Impossible event. That is probability of getting 13. Probability of getting a 13 is 0. Third question. Less than or equal to 12 is what? Any number which we get here, right, will be less than or equal to 1, right? Because if we add all the numbers, see, this is less than or equal to 12, this is less than or equal to 12, this is less than or equal to 12, this is less than or 6 comma 6 is also less than or equal to. So this is actually a sure event. So all the numbers 36 by 36 or 1. So 1 is the answer for this question.